Okay, now we're going to look at transforming the basic reciprocal function. F of x equals 1 over x, graphed below. And we have to transform it into y equals f of x minus 1 plus 2. And of course, this is function notation used to summarize some transformations. And hopefully you recognize subtraction and addition, which means our basic reciprocal function has been translated. So we can start to translate points initially, and that might be a good place to start because you're more familiar with that approach from our quadratic chapter. If we take these 3 points in the positive branch here and we move those, remember 1 unit to the right, x minus 1 is a translation 1 unit to the right, and 2 units up, we can go 1 unit over from 1 and 1 and up 2 right into here. And I better change my color. And I'm finding it already, and you possibly are as well. It's a little bit awkward to be counting from this dot over to a fresh piece of graph paper. So what's really helping me when I translate a basic reciprocal function is to actually translate the asymptotes first, of course, which is the y and the x-axis to begin with. So let's try that approach. If I recognize my vertical asymptote was the y-axis, that, of course, vertical asymptote gets moved over 1 unit to the right. If I can line this up correctly here. It's not too bad, and I'll fix that in a sec. There's our new vertical asymptote, and similarly, my horizontal asymptote from the basic reciprocal function was the x-axis. It gets moved up precisely 2 units, so let's sketch that as well. At least attempt to here. There. Okay, so I'm going to notch this out so it resembles. It's a good idea to have use a dotted line or faint line for your asymptotes. It might be taking a while here. We'll go fast. Okay, so I think that resembles a dotted line. Okay, so those are our asymptotes, and now as you can see, it's easier for me just to copy the, configuration of those 3 points over on this graph paper now. Because of course space from those vertical and horizontal asymptotes is over 1 and up 1, and then from there I can go over 1 more step, half of a box, go over 1 more step, half of a step to the left and go up 2 boxes, and you can easily see you got your positive branch of your basic reciprocal now located up here, which we'll try to connect smoothly, which as always is easier said than done. That's not bad. So that's that branch, and I'm going to exaggerate those points again so we can still see them. Okay, and on the negative branch of our basic reciprocal function, we of course have these 3 dots, these 3 points. And as long as we can get those in our transformed version, I should say our translated version, I'm going to of course go a step down and to the left from my asymptotes. And it lands us right here in the wrong color. Temporarily at least. There is our first point, and then if I go 2 steps over, that's a half of a box under, half of a box over, 2 down. So of course you better know your ordered pairs in your basic reciprocal function well, so you can quickly sketch a translated version of this, and I will attempt to sketch those points, connect them. And there we go. There's our translated reciprocal function. And before we move on, let's have a quick look at, what is the equation of this function? Because of course that gets confusing because this is an equation, but this equation is designed to describe the transformations that happened to go from 1 over x into this graph function that you see in front of you. So what is the actual equation for this transformed reciprocal function? Well, we'll do it in pink. We'll say it's y equals. Now the easy part is adding a plus 2 at the end. And my original function was I had to take the reciprocal of just x, right, which matches the input in that function. And now I have to take the reciprocal of x minus 1. So our input location, which used to be x in the denominator here, switches to x minus 1. And this is the explicit equation. explicit equation for this exact reciprocal function that we graphed as well. And note, if I look at this explicit equation, positive 1 gives me division by 0, which corresponds to our vertical asymptote, and plus 2, this big plus 2 right here, of course, corresponds to our horizontal asymptote, which is sketched above. And one last thing, let's have a quick look at how you could sketch this on your graphing calculator if you're having some difficulties. But you should be able to do it paper 1 and paper 2, of course. So there's our basic reciprocal. And in here I can say, can you translate that basic reciprocal function 1 to the right and 2 units up? And there it is in red. Of course, it's our same function. And this gets pretty busy with both of these functions. So let's go shut off our f1 of x by just clicking on that. And I think just to make sure you're able to sketch both of your asymptotes, I'll include that quickly here as well. So since one of our asymptotes is not a function, it's a vertical line, we have to change our input method from function to relation. And now I can say, can you graph x equals 1? And can you graph y equals 2? And you can see, probably should drag those labels out of the way or hide them. Probably should change those with a right click to match our function. And most importantly, if we right click and select attributes, we can actually go down and change it to a dotted line or a dashed line, which is usually the way you would sketch your asymptotes. There. And you can see now you can trace and move around and get a better idea of what's happening to your function as you go far left and far right. But I think that's pretty clear that we have a vertical asymptote at x equals 1. And note the equation of that asymptote is exactly x equals 1. And our horizontal asymptote has, of course, an equation of y equals 2 as labeled on our screen.